So in this slide set, we are going to look at the high-low method. The high-low method allows us to take 2 points of data and use it to separate out a mixed cost into its variable and fixed portions. So let's revisit cost behavior. As we've talked about in previous chapters, a variable cost is a cost that's constant per unit and varies in total. A fixed cost is a cost that is constant in total but varies per unit. And now we're going to introduce this idea of a mixed cost. A mixed cost has some portion that's variable, some portion that's fixed. It varies per unit and it varies in total. So let's take an example and look at cost behavior and trying to determine cost behavior. So in this example, we have three costs: cost A, cost B, and cost C. And we've decided that we think production drives cost. So in January, I made 10,000 units. February, I made 40,000 units. And the total cost for A, B, and C is given in this example under those circumstances. So let's look at cost A. Notice that when I made 10,000 units in January and when I made 40,000 units in February, the total cost for cost A was $20,000. Let's look at it a little further in a cost per unit form. So if cost A is $20,000 when I make 10,000 units, well, that's $2 per unit. Yet in February, it was $20,000 when I made 40,000 units. So that comes out to be, per unit, $2 in January, 50 cents in February. When I look at cost B, 50,000 in January, 200,000 in February. And when I go to get the per unit cost, when I take the $50,000, divide by 10,000 units in January, I get $5 a unit. The same is also true in February. When I take $200,000 and divide by 40,000 units, I get $5 per unit. And then I look at cost C. Right? In January, it was $40,000. In February, it was $100,000. When I divide by the respective amount of units produced, I get $4 per unit in January, $2.50 per unit in February. So what does this mean? Right? When I look at the per unit cost in conjunction with total cost, well, let's think about our cost behavior. The definition, if we remember, of a fixed cost is that it is constant in total, varies per unit. So when I look at cost A, it was constant in total for January, 20,000, constant in total for February, 20,000. But notice that the cost per unit varied. $2 in January, 50 cents in February. This is, right, a fixed cost. The true definition of a fixed cost. Constant in total, varies per unit. When I look at cost B, I can see it was 50,000 in January, 200,000 in February, not constant in total. Therefore, it's not a fixed cost. When I look at the per unit, though, it is $5 in January, $5 in February. So this is something that is constant per unit, varies in total. This is our definition of a variable cost. And when I look at cost C, I see that in January it was $40,000, February $100,000, so it's not constant in total. And when I look at the cost per unit, $4 in January, $2.50, it's not constant per unit. All right, so this is a cost that is not constant in total, not constant per unit, therefore it is a mixed cost. So with the contribution margin statement, it really helps if I know variable costs and fixed costs. There's no place in that statement for mixed costs, so I need to separate out the variable cost and the fixed cost from a mixed cost because mixed costs include some of both. So I need to be able to separate those out. One of the ways I can do this is using the high-low method. So I'm still going to assume that variable costs are constant per unit, fixed costs are constant in total, and I am going to use a formula to solve. So the first thing I want to calculate is variable cost per unit. So I am going to take the change in cost from the high activity and the low activity. I'm going to look at the total cost, right? I want to pick 2 points because that's the beauty of high-low. I only need 2 points of data. But be careful that we pick 2 points of data that aren't outliers, right? Because garbage in equals garbage out. But assuming that these 2 points of high activity and low activity, I know the total costs are representative of the population of data, I want to take the change in cost from high to low and divide it by the change in activity from high to low, and that's going to give me variable cost per unit. Then I want to calculate my fixed cost by substituting in either high or low in the formula. And I know the formula is this. Total cost should equal my fixed cost plus my variable cost times the activity that I think drives that cost. So since I know that's the formula of calculating my total mixed cost, well then I will take the information I know for either high or low, it doesn't matter which, substitute it in, and this will leave fixed costs still unknown. It's like our X that we need to solve for. And once we do that, we can create a formula that gives us the total cost based on our steps in 1 and 2. So let's take an example. In this example, I've got 5 months of data: January, February, March, April, and May. And it appears that we seem to think that the units sold are the activity that seem to drive cost. And the question reads, if given the presented data and we plan to sell 27 units in the following month, what would we think our expected cost would be? So we're going to use high-low, and I need to pick the 2 points of data that represent high and low activity. Be careful, it's always based on activity. And when I look, I see that April is my low activity at 15 units sold. February is my high activity with 30 units sold. And therefore, we're going to ignore the other points of data and focus on February and April. So step 1, I need to determine the variable cost per unit. So I am going to take my change in cost, $1,750 in February and $1,375 in April, and the difference is $375. Then I'm going to divide into that the change in activity, the units sold, 30 units in February and 15 units in April, giving us 15 units change. And when I divide through, that's going to give us our variable cost of $25 a unit. Step 2 is to calculate and solve for fixed costs. I can do this by substituting into the formula, which I know is total cost equals fixed cost plus variable cost times the activity. I can substitute into high or low. So let's go ahead and substitute into high. When I know the total cost is $1,750, I know that equals some unknown fixed cost that we're going to solve for, plus the $25 per unit that we just solved for in step 1, and we're going to multiply by the activity that we had at high of 30 units. And when I do that, I can solve that fixed cost equals $1,000. If I had substituted into low, I would have also calculated that fixed cost equals $1,000. It doesn't matter whether I substitute into high or low. So once I do that, then I can come up with my cost formula. All right, this mixed cost should equal a fixed cost of $1,000 plus $25 per unit sold. So when the question asks, what would I anticipate my cost to be in June if we sold 27 units? Well, I'm going to substitute the 27 units into this formula. And when I do, right, I take the fixed cost of $1,000 plus the variable cost of $25 per unit times the 27 units, I will come up with $1,675. This is what I would anticipate our total cost to be in June if I plan to sell 27 units. So here's an example I would like you to try on your own. Meet me on the next slide, if you will. Okay, let's do this. We know step one, right? Step one is to take the change in total costs, right? 32,000 minus 20,000 equals 12,000, and divide by the change in activity, the 2,000 units minus the 1,000 units. And when we take 12,000 and divide by 1,000, we get a variable cost of $12 a unit. I can substitute into high or low in step two. Let's go ahead and substitute into low. I know at low, right, 1,000 units produced, my total cost was $20,000. And I know that total cost of $20,000 represented some fixed cost unknown to us that we're going to solve for, plus the variable cost per unit that we just solved for, $12 a unit, times the activity at low, 1,000 units. So when I substitute in, I have on the left side of the formula 20,000, on the right side of the formula 12,000, and I can solve for fixed cost to be $8,000. Again, note that if I had substituted into high, I would have come up with the same fixed cost of $8,000. Once I know this, I know what the total cost formula is, right? It is $8,000 fixed cost plus $12 per unit. And this question says, using high-low, determine the factory cost if the winery produces 2,300 units in August. So I just want to substitute the 2,300 units into this formula. And when I do, well, then I come up with $35,600, which was answer D. So now we finished the high-low method, and now we're going to take this knowledge and use it with cost volume profit analysis. Get excited.